All right. So, good morning or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. Today, we're doing a little bit of all three of those things, which is a lot of fun. Right now, we're joined by 6 classes from across North America, so I want to give them a chance to do a bit of a shout-out. We've got Mrs. Sapella's grade 4s in Manotick, Ontario. Hi, guys. Hi. That's a lot of hands. I love it. We've got Mrs. Reading's grade 3s in Freehold, New Jersey. Freehold coming through with excitement as always. We've got Miss Rodriguez's grade 5s in Odessa, Texas. Hi, guys. Hi. Awesome. We've got Miss Bradfield's grade 2s in Courtenay, BC. Hi, everyone. And then 2 classes that are having a little bit of mic issues, but we've got Mrs. Damianakos' grade 4s in Nepean, Ontario, and Miss Boyle's grade 6s in Halifax, Nova Scotia. Without further ado, the reason you guys are all here joining us today is for our speaker. So we are joined live in February, our entire month dedicated to amazing women in science, by Rachel Bell Irving at Oceanwise, Vancouver Aquarium's at Oceanwise, who's going to share a little bit about coral reefs, research on them, and a little bit about the amazing habitat jungles of the sea that comprise reefs. So without further ado, thank you so much, Rachel, and take it away.
Thank you so much, Jesse. Good morning, everyone. I hope you're all having a great day wherever you are located. As Jesse said, my name is Rachel. I'm currently located at the Vancouver Aquarium, which is in Vancouver on the western side of Canada. We are right in the heart of Stanley Park, which is on the traditional territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations peoples. So I am right in the middle of a rainforest, both on land and underwater, which is super cool. But today we're going to go exploring a different ecosystem. We are going to explore the amazing coral reef ecosystem that I have behind me here in front of our sharks habitat. So you might see a few curious critters swimming around, and we'll have lots of time to talk about them afterwards as well. I do have a presentation that we will share with you talking about coral reefs. Oceanwise is an organization, we're a non-for-profit that is globally committed to the conservation of ocean life and also talking about it. That's why we're here today, is to talk about and learn about some of these amazing animals. The better we can understand these incredible world that we have, the more adept we'll be to protecting it in the future and making sure that other humans down the road have a chance to appreciate as well as get the resources we need from the amazing oceans. So I'm going to share my presentation with you all, and we're going to talk about these really cool animals. You're going to see Jesse for just a second there, and then I've got my wonderful presentation. So here is the Vancouver Aquarium. If you ever get a chance to come to Vancouver to visit us, we would love to see you. As I said, we're a non-for-profit, so all of the proceeds go directly back to helping our animals and contributing to research. And one of those really important animals that many people forget about are the invertebrates. So I'd love for everybody to touch your neck, and you'll feel how there's these bones on your back, and you've got bones in your arms, and you've got bones in your legs. These make you a vertebrate. It means you've got a spine that gives you structural support. But there is an entire group of animals called invertebrates that have no bones. These actually make 97% of animals on Earth are invertebrates, including bugs, crabs, shrimp, snails, all these amazing animals. And today we're going to talk about an invertebrate that looks something like this. Some of you might have seen this animal before. You might have even gone swimming with this animal. I hope not. It does hurt if you unfortunately get stung by one. And when we're scientists and we uncover an animal out in nature, we like to first make observations. And that's how we've been able to classify a lot of these animals, is by making observations and seeing what characteristics these animals have and which animals share the same characteristics. So today we're talking about a very specific group of animals called Cnidarians. Cnidarians are best known for their stinging ability, which is why we've got our lovely jellyfish here in front of us, because they have those great tentacles that are used to sting either predators or prey. They don't have a brain, they don't have a heart, they're just really eating, pooping, and stinging machines. And aside from that stinging ability, the other thing that we know Cnidarians have is radial symmetry. Basically means no matter which way I cut it, we're going to have equal pieces. So we often see this bell shape, this circular shape that makes up the top of the body. This is what a lot of radial symmetry looks like, and this is why we know they're also Cnidarians. So these characteristics are really important. It's how we identify jellies to be part of this phyla Cnidarian, and it's also how we can group other animals to be a part of this group as well. And that's why I wanted to introduce you with this example of Cnidarian, because now we're going to talk about their cousins, essentially. We're going to talk about corals. Now, corals are a part of the Cnidarian family, so the first misconception we're going to bust is the fact that they're animals. You are looking at a picture of hundreds and hundreds of animals. Many people mistake corals for plants, but in truth, they actually are living animals. More specifically, they are colonies of animals. So a coral is a colony or a group of tiny animals living together, and each individual animal is called a polyp. So here's a zoomed up view of a soft coral. We can see each of those individual little polyps that together, because they're living within a colony, they make up corals. Sometimes polyps are as big as a baseball. Some are too small to be seen by the naked eye. And when you get up close to a polyp, you start to see that they kind of look like tiny upside down jellyfish that have been stuck together. So polyps also have radial symmetry, that circular shape, and they have some kind of stinging tentacle as well that they're going to use to catch their food and protect themselves. So when we get up nice and close to those polyps, we can see how similar they are to jellyfish and why they're also part of that Cnidarian family. Sometimes you just have to take a little bit of a different perspective when you want to get up close to something interesting. So these individual polyps, they join together, and as they join together, they form a skeletal structure that's made out of calcium carbonate. Now, you've probably used calcium carbonate, likely in the classroom. The common name for it is chalk. Chalk, otherwise known as calcium carbonate. And this is why corals make up these incredible structures, because once those polyps join together, they form this incredible jungle gym-like structure out of the calcium carbonate. And it also, if you ever used chalk, it also means that it's quite fragile. So we find corals in warm waters, usually tropical waters, but we also find them in cold water as well. This is a cold water coral that we often see when we go diving as ocean-wise researchers. We go diving up in the Arctic as well as along the West Coast, and we do see cold water corals there as well. Thanks to these corals, whether they're the tropical areas or if they're in the cold water, they provide support for all walks of life in the ecosystem. They're food for some of the animals. They can also provide a place for them to hide from their predators, or even for predators to hide to ambush their prey. And this is why I call them the jungle gyms of the ocean, because they are that bottom structure that really helps to support the entire ocean ecosystem they're a part of, specifically when we get to tropical waters, because in tropical waters, they live very dense and very close together. Now, of course, being tiny also means that you come with a lot of many different challenges, and you have to be able to survive. Like I said, their calcium carbonate structures are very fragile. So corals can take hundreds of years to grow, and they can take 30 seconds to break. For example, if we're not careful when we go swimming near corals and we accidentally kick one, for example. So that's one of the challenges, of course. There's our wonderful Wobbegong Shark. I love the Wobbegong Shark. It's a great master of camouflage. It uses the corals to hide so that it can ambush its predators. And so inside those polyps, because they're so tiny, they have to have a way of finding food. They have a relationship with a type of algae. And this algae is called zooxanthellae. You can try and say it out loud. Zooxanthellae. Zooxanthellae is the algae that lives inside each of those individual polyps. And the zooxanthellae and the polyps work together to make sure that they are able to find food. Zooxanthellae, because it's an algae, it acts like a plant, which means it's able to take sunlight and it's able to produce food for the corals. Now, this is great for the corals because of their stinging tentacles. They can protect the zooxanthellae and they get some food. So corals produce a lot of oxygen for us as well. Now, the challenges that we're finding for a lot of zooxanthellae is that the ocean is getting warmer, and this can stress out the zooxanthellae living inside the corals. And so if you've ever heard of coral bleaching, This is a really great illustration done by the National Ocean and Atmospheric Association down in the US. And this is a great way to explain why we get coral bleaching. It's a very common problem right now, particularly in tropical waters. And it's because the coral and algae are depending on each other to survive. And when it gets too warm, the zooxanthellae get stressed out and they'll actually leave the corals, which this means the coral is now abandoned for its major food source. The algae will provide up to about 80% of their food. And now, because they're so stressed, they've run away and the corals are left without their color. Once the algae leaves, that coral loses its color. Now, a bleached coral can survive, but it's going to be a lot harder if they don't find a better food source as well. So everything in nature is connected, it's balanced, it's working together. And if we're not careful with how we interact with these environments, then humans are having a direct impact on it as well. So here we've got a picture of a colored coral as well as a bleached coral to see the difference of what happens when even just a tiny change in the temperature can have a really big impact on some of these most sensitive animals. So it's a good indicator for humans to know what exactly is happening. If we see corals are suffering, we know something's going on. And research is showing that the oceans are getting warmer at a faster rate than we've seen in the past, which can be kind of alarming, particularly because these corals are such an important foundation for the ecosystems that they're found in. So, So that's why corals are super important. They are that building block for the entire ecosystem that they support, whether it's food, whether it's giving oxygen, places to hide for predators, for prey. And this is why we want to keep talking about it, because even though corals might seem like they're far away, we have an impact on that just as much as those local communities. The water around the world travels everywhere. From a drop in your water bottle can go around the world and back before you actually drink it, which is kind of cool to think we're so connected to another part of the world, which means that how we interact with our water also might have an effect. And corals, in terms of conservation, can be really challenging. We know they're important. Research has shown us how much they support these incredible ecosystems that give humans that give humans oxygen, that give us food, because the fish that we eat might hide there, the crabs and shrimp that we eat might hide in there. We know that corals are important, but it's hard to get people to really care about corals because they take forever to grow. They take hundreds and hundreds of years to grow. And so people don't often understand just how incredible they can be because they're on the other side of the world. So talking about these important issues like you're doing today is a really good first step. And I encourage you to go out and share something about corals with someone that you've met today, either in your class or at home. Talk about the ocean and see how you use the ocean in your life, whether it's the air you breathe, maybe you eat fish, maybe you actually have a stream near your house. There might be something that you're connected to. So go out and explore and keep talking about the ocean, because that's the best thing that we can do to start to help these amazing, amazing, amazing animals. And so there is the quick corals are. They're tiny little polyps living together in a colony, working with algae to find their food, and they provide the foundation for an entire ocean ecosystem. Incredibly important creatures. And I would like to know if you have any questions about corals, about invertebrates, coral reef ecosystems, or the aquarium.
Of all the presentations you've done, I think you're actually most enthusiastic about corals, so that's awesome.
I love little animals. They're so cool.
So we're going to start with some questions. I want to know we've got a few groups watching on YouTube Live. If you guys want to type your questions in the chat bar on the right, I will pass them along to Rachel directly, so please do that. And then Miss Boyle's class, if you guys want to type in questions here in the chat bar, top left of your screen, great. Miss Damianakos, you might need to do that too. We'll check it out. First, though, we'll go to Miss Sapella's class. If you guys have a question to kick us off, go right ahead.
Can a coral be considered a rock?
Oh, it cannot be considered a rock because it is alive, but it does trick people because it looks very much like a rock. So good question, but it is an animal, not a rock.
To that end, though, so it's really interesting with coral skeletons over time. So if you look at cliffs that are limestone, are those like, that's a rock? Is that maybe what we're getting at? I don't know. Rachel?
Yeah, so that's a good point. So the skeleton that a coral builds, that could be considered a type of rock because it's not living. The animal that lives inside the skeleton, that's living. So the cool thing is that when they add to their skeleton, it gets bigger. Top of rocks that they've made, but that top animal is an animal, they're sitting on top of rocks. I think that's a good way to put it.
Okay. Excellent. Jimmy in Miss Boyle's class wanted to know, how big and small can corals get?
Yeah, there's a huge diversity, Jimmy. Sometimes corals, you need a microscope if you want to see the polyps, so the individual animals. Sometimes those polyps can be as big as a baseball. Like one polyp can be that big, and they live together. So corals themselves, as the colony corals, can be like, they can create these incredible cliffs, mountain ranges. As long as they get the opportunity to stay safe and keep growing, then there's really not a huge limit. So we get in massive fields and these really cool rocky terrains. It really is like the most complex jungle gym you can picture. Like picture your school jungle gym and then add 10 of them all the way around. It's crazy.
All right, let's head to Mr. class. If you guys have a question, come on up.
Oh, go ahead.
Freehold, yeah, no hurry, guys. All good, sorry.
How can we grow a new coral?
How can we grow new coral? I love the way you're thinking, and there is a lot of research that's going into that. It's challenging because they take so long to grow. We have to be able to give them, again, a safe place and some kind of structure to stick to. So we need to give them like a rock or some kind of safe, hard structure that they can stick to. They don't grow very well on sand. So we actually do have people coral farming, essentially. They'll actually take little bits of corals. The cool thing about corals is that they can clone themselves, some species. So they take little pieces of corals, they make a little garden, and they let the corals grow. And if you give them time, that's the #1 strategy we're seeing right now, is really trying to regrow corals.
Excellent. All right, so Miss Demi Nagos' class, I know you guys just sent in a question on YouTube Live, but let's see if we can get your mic working. Let's see if it's good. I don't know. So you're demuted, and if not, then I'll just pass along your question. Yeah, I don't know. Sorry for the tech difficulties, guys. So the question from that class is how many types of corals are there, Rachel?
Oh, that is a really good question. I actually don't know the specific number. I'm sorry. I should really know that off the top of my head. There is a very wide diversity. The cool thing about corals is they can be hard corals or soft corals. So we get corals that might look like that rocky cliff structure, and we get some corals that actually look more like seaweed. So I don't know the specific number, but I can tell you they come in a huge, wide range of colors and shapes and sizes.
Very cool. All right, let's hit to Ms. Rodriguez's group. You guys have a question? So many of you.
Can a coral or a polyp be taken out of water?
It won't survive out of water. Thoughtful question, but they are designed for water. That's where they get their oxygen from. It wouldn't survive if we brought it out of water.
Yeah. One of the things that a lot of dive operators and tour groups around the world really like to highlight to people is that you shouldn't touch coral at all. You should always just stay away from it because it's very delicate and it's very easy to hurt and destroy coral that take hundreds of years to grow. So good question.
And it's for your safety too. I did a research dive in Cuba, and there's a type of coral called fire coral that it looks kind of like antlers, but if you touch it, it does feel like a burn. So there are certain species of corals that we will physically be hurt by as well. So it's better just not to touch it at all.
Quick follow-up, why does it burn? What's going on?
So because they're cnidarians, they're able to sting. They've got their tentacles, and they basically the same way a jellyfish would sting you.
Excellent. All right, Miss Marks's class, if you guys have a question. Come on. Yeah.
What would happen if there was no coral reefs?
If there were that's a very thoughtful question. If there were no coral reefs, then that entire home for the animals is really going to suffer. So because it's a great hiding place for baby fish, those baby fish wouldn't have a place to stay safe. They would be eaten by predators. All of the little animals like crabs and snails and all the kind of cool things that we might eat or that might be food for other animals don't have a place to hide. It's pretty much like if someone just suddenly took away your house. So you might survive, you might have to find a new place to live, but then your home is destroyed. And that's really sad too. So it would be very challenging for a lot of animals.
Yeah. All right. Glad we got that question. Very thoughtful question. Let's go to Miss Sapella's group again. If you guys have a second question, come on up.
When did you realize coral was in danger?
I think that's a great question. I'm not coral research goes back a couple of decades, so it's been quite a few years. But I think in my life, in the last 20 years, it's become more and more talked about because we've got things like media and newspapers and things like that get to highlight it. So coral research has been going on for a long time, but people are now starting to pay attention to it because other people can travel around the world to go visit corals, which is exciting. Research has gotten better and more in-depth. So it's within the last 20 years or so that it's really started to be talked about around the world, but we've been researching corals for quite a long time. So it's kind of scary since the Industrial Revolution, which I think was in the 70s. I'm gonna get that wrong. My history is a little bit rusty. We've been noticing changes, but it's in the last 20 years that we're really like, something's really like,
Abby in Miss Boyle's class wanted to know, so if coral reefs all die out, again, tragic scenario here, does that affect our oxygen? Does it affect oxygen in the water at all? And if it doesn't, is there anything that does affect oxygen in the water?
That's a great question. So when mentioned with the zooxanthellae, the algae living in the polyps, they do photosynthesis just like plants on land, and that's how they're able to get food and they produce oxygen. So yes, if we lost all of the coral reefs, there would be an impact on our oxygen. It likely wouldn't be detrimental, like we probably wouldn't suffocate from that. But if coral reefs are suffering, it means that a lot of other animals, like other algae, are suffering too. So because the ocean provides us with over 50% of the air we breathe, if coral reefs are suffering, it's likely that other important animals like kelp and other algae that give us oxygen would also follow. So it's definitely something to be concerned about because then we do lose a major oxygen source. And protecting those kind of vegetations underwater is really important for that big reason.
Okay. Let's head back to Miss Reddy's class. You guys have a second question?
Can coral get its color back after it dries out?
Good question.
Yes. So just because they're bleached doesn't necessarily mean that they're dead, which is good. There's a chance. There are some zooxanthellae, there's actually a couple different species of them, and different corals match up with different algae. So some corals are more affected than others. If it keeps getting too hot, then they're probably all going to be affected. But there is a chance that if the temperature cools down, the zooxanthellae could return, or maybe after a couple of hundreds of years, the zooxanthellae might adapt to the warmer temperature. So it's not necessarily going to kill them. There's a chance, but it's very difficult for them to recover. So it also makes them vulnerable to disease and sickness because they're not as strong. So it's possible, but it's very, very hard for them to recover.
Yeah. All right, Miss Demianakos' class wanted to know what kinds of animals eat coral.
Hey, there's actually quite a number of fish species that will eat corals. Many of them have these specialized mouths, often look like beaks or big teeth that are meant specifically for chomping down on the algae. And then there's some fish that will, there's with certain types of fish that will like remove the algae so that they can, remove the coral so that they can grow the algae that they want to eat and things like that. So as much as corals provide a home, sometimes they're also competition for some animals. And that's a big threat to them too. So there are lots of fish specifically that will eat corals.
I just wanted to follow up quickly, Rachel, with this idea that certain maybe tropical beaches with their beautiful sand might, stem from some of those parrotfish and what they're eating. Could you explain a little bit about how that gets formed and how if you eat coral and poop it out, say, that might change the composition of beaches?
Yeah, so sand is really just broken up pieces of animal poop, bones, shells, all that kind of debris from the ocean. So if we have an imbalance where like parrotfish eating all of the corals, then we get a really expansive beaches. So great for people, not so great for the animals that need the kind of places to hide for their home. So balance is really important. If there's too many parrotfish, then they are really overwhelming the corals, and that can be dangerous as well. And we get great sandy beaches from their debris, but not so much for the animals that need the corals.
Awesome. All right, let's head to Ms. Rodriguez's class. You guys have another question?
How long is the normal lifespan for a coral reef?
That's a really cool question. Corals can live to be hundreds and hundreds of years old. If they keep on surviving and nothing destroys them, then they can be centuries old, which is really cool. Again, they just have to make sure that they are not broken or eaten or whatnot, which can be a harder thing to do in the wild. But yeah, they can live to be hundreds of years old.
All right, let's head to Ms. Marks's class.
What is the life cycle of coral?
Oh, what is the life cycle of corals? That's a great question. Corals and jellies and sea anemones, they all start off, it's not a strong suit of mine, to be honest, but I do have a picture of, I can explain it better with jellies. So jellies, for example, because they're swimming, they actually start sitting on the ground. They start off with their polyps. They build like a little tower and then it pops off. I actually do have a video of this. So if I go back to here, this is our jellies being born. And so corals are very similar. Corals will release their gametes, their sperm and their eggs and all that. They'll release it into the water. They hope it mixes and then it settles down into the ground. And that's when the corals start to form. Jellies are the reverse, where they start off swimming and they do this.
Hi, my name is Mackenzie Neal, and I'm the Assistant Curator for Propagation, but I'm also known as the Jellyfish Queen. Strobilation is the process by which polyps start dividing and they produce a phyra, or baby jellyfish. You can see that there's a bunch of them that have started strobilation. You can see the separation on some of the polyps where the discs are forming. There's two really nice clumps of a phyra. One of those clumps just fell off. Usually they pop off as individual phyra, but sometimes, like you just saw, they come off as clumps. And those phyra will continue to break away and start swimming away and grow into adults.
So jellies are that way, and then corals do this, where because they're stuck on the ground, they have to release all their eggs into the air and hope that they mix and then settle back down. So it's called broadcast spawning, where they start off with the little babies, and then they'll stick to the ground, and then they'll hope that they mature into adults. And jellies, when they're mature, jellies will then pop off and start swimming, which is quite cool.
I love that we both got jellyfish, which is the coolest thing, that they appear on a stalk, is one of the neatest things you can ever learn in nature. And I really urge the classes, when you're done, look up more videos of corals spawning, so when they lay their eggs, because it's like fireworks underwater. It's like nothing else on Earth. It's one of the most beautiful things ever in nature, ever. So you check that out.
Jellies start sitting and they end swimming, and corals and sea anemones start swimming and then they end sitting.
Excellent. Good point. All right, we're whipping through these guys, so we have time for another whole round of questions. So for the two classes that have to type them in, I think you already have, which is great. But we'll start again with Mrs. Sapella's group. You guys have a question? Come on up.
In different places, is there different types of coral? Like, does the coral look different, let's say in Australia than Vancouver?
That's very clever. Yeah, they do. So different species are better suited for different environments. So you get a little bit of differentiation between places like Australia versus the Caribbean, kind of South America area, Central America, sorry. So yeah, and then cold water species are an entirely different group. We do get a bit of diversity amongst the regions as well.
Excellent. All right, the question from Ms. Boyle's group from C. Oh, so Sam wanted to ask, does coral need sunlight? And if so, how does it get to the coral, especially for deeper coral?
Yes, great question. So the tropical corals definitely have to have sunlight. They're very reliant on that photosynthetic relationship with the algae. So you tend to find corals quite shallow, which is why it can be a conflict between humans and corals, because where corals live is usually the depths that we tend to go swimming at. So that's why they live shallow, is because they need the direct access to sunlight. And sunlight can reach down a couple meters. For the deep water coral, I haven't looked into them as much, but it seems that they don't need sunlight because they can't access sunlight. So they have to find other ways of finding their food, which is when those stinging ability really comes into play, because it means they can catch food that is floating through the water column around them. And so they're going to rely more heavily on food they find as opposed to the food that they would get from sunlight.
Awesome. All right, Mrs. Damianakos' class wanted to ask, what's the most common coral, if you know, and do they camouflage, or do coral in general camouflage?
I don't know what the most common type of coral is, unfortunately. That is a cool question, and I'm going to go look it up later. But in terms of camouflage, what's really neat is a lot of fish species really have started to camouflage to match the coral, because as an animal, the corals become a setting, which is quite neat. So you see fish that will have the same kind of bright colors, because when you get underwater, those bright colors will mesh really well with the corals. And when you've got a really chaotic setting, if you've got chaotic pattern on you, then you blend in really well with the busyness that's going on in corals. So we see some animals that are now camouflaged to suit corals, which is quite interesting.
Very cool. All right, Miss Redding's class, if you guys have another question, come on up.
Where do you find the best corals?
Where do you find the best corals? I've been told that, so the coral bleaching event, unfortunately, is happening worldwide. We're seeing a majority of the damage being done in Australia is probably the most famous one, the Great Barrier Reef. I've been told that by fellow divers, the Maldives are currently still doing better than most other areas. So if you were to be scuba certified and you really wanted to go swimming or snorkeling with corals, and you wanted to do it safely and respectfully, the Maldive areas, those coral reefs are still, they're not quite as damaged as the rest of the areas. Unfortunately, if we don't start trying to find solutions for this, then they'll eventually catch up with those other areas as well.
Excellent. And I want to note for our classes, especially our older classes, 10 years old. At 10 years old, you can get scuba certified. You should do it. It's the greatest thing ever. Go now, immediately. A lot of fun. All right. And we'll take two last questions. So Miss Rodriguez's class, if you guys want to ask another one.
Let's go. Come on.
No hurry, all good.
Hurry, Bryce.
How would a coral protect themselves?
Great question. They're tiny, but they're mighty. Many of them can use those stinging abilities to protect themselves. So that's a great way to defense against the fish that might want to eat them, for example, or humans that might want to touch them, for example. So predominantly the stinging ability is what's going to protect them. And the nice thing too is by living in a colony, that is a form of protection, because hopefully if you all live together, fish do the same thing. Your buddy is going to get eaten before you get eaten, hopefully. So another reason why they like to live in big groups too.
That's funny. All right, let's do one last question from the girl who's been waiting so patiently. So Miss Marks' class, if you guys have one last question, go right ahead.
How did corals evolve so differently than jellyfish?
Ooh.
Very good question. We don't entirely know. So this is the really exciting thing about science, is that that's the puzzle we're trying to solve, is by looking at hopefully artifacts we can find in the ocean, by studying the genetics of corals, we can understand why they became so different. It's usually because of something in the environment. So for example, the best example I can think of is sharks, because sharks are so different. That's because some of those sharks, they evolved to live out in open water, so they're really big and strong swimmers, when other sharks evolved to live in the corals, so they tend to be smaller and they tend to be more colorful. So corals might have had a similar pressure where maybe it was just better for them to be stuck to the bottom and to build their own structure as opposed to swimming around, but it's still kind of one of those mysteries that we can hopefully look into as scientists.
Nice. We've had some really, really great questions today. So thanks to all the classes. Some really like questions that adults and university students would have. So well done, guys. All right. So for all our classes, what we do at the end of every hangout is I'm going to demute everyone's microphone. And so boys and girls, if you guys could get ready and joining me and saying a huge thank you to Rachel. Everyone is now muted. So go right ahead. Thank you so much. Awesome. I love it. The classes that didn't have the mic typed in. Thank you. That's amazing. So classes, thanks so much. Again, all February long, amazing women in science. Ocean-wise, if you're keen on more of the great work that the Vancouver Aquarium does, we do tons of hangouts with them. We have tons on YouTube already, so please do check that out as well. And Rachel, thanks so much for joining us once again. Always